Now, Harman's hypothesis would have been relevant at that time, and you said in the 50s, early or mid-50s, you were doing this kind of post-grad work?
Yeah, in the 1950s, there were lots of new discoveries. Daniel Madzia and his collaborator, Katsuma Dan, discovered how the mitotic apparatus works that controlled cell division. And they found that the reduction of the sulfur groups, sulfhydryls, increase at the time of cell division. And if you look at those as the interface between metabolic energy production and cell growth and differentiation, it suggests a very direct course to curing the tumor-producing diseases at least, and the inflammatory diseases by working on metabolism. The genes are only in the background, don't have any role in therapy actually, except everyone has to have genes.
Well, to produce proteins and everything else. Okay, we'll get into a little bit later how the gene theory has been totally discredited in a lot of ways in terms of the evidence that we'll bring out in some of these abstracts. But in terms of what interested me when I started reading these abstracts and articles was that I think a lot of people recognize the term oxidant and antioxidant probably erroneously, and we've always looked at antioxidants as being the things we were necessarily looking for, when in fact when they've done autopsies in the brain, they find things like glutathione, which is one of the main antioxidants in the system, is actually not that depleted, and so they're looking at other reasons for aging and cell death, etc. How is your current understanding of antioxidants different? Because essentially, what I think you're trying to say was that oxidants really should be termed, antioxidants should really be termed pro-oxidants. The ones that are therapeutically useful, such as vitamin E and vitamin C, actually shift the balance inside the cell. Vitamin C is known to be in a very highly oxidized condition, so it isn't really the vitamin C we know. Right. It's dehydroascorbate when it is inside a healthy cell. Okay. And these are maintaining it's actually a constant flow of electrons, but the balance at every moment is pushed in the direction closer to oxygen and farther from the reducing electrons. And so if you're deficient in vitamin E and vitamin C and so on, the electrons predominate and shift over to reducing the sulfur groups all through the cell into the sulfhydryl form, promoting inflammation. And if you think about what happens when any kind of injury happens, whether it's a microbe or getting stuck with a thorn or whatever, you disrupt the ability of the organized tissue to deliver oxygen and sugar and other nutrients to the cell. Right. And so the cell in that area is starved, can't oxidize, and it has an immediate shift over to the basically the antioxidant side. The cell has a variety of enzymes that function as antioxidants, but they are only activated during injury or stress. And what happens to the cells in that condition is the sulfhydryls are reduced, the mitotic apparatus is activated, the cells de-differentiate, lose their functions except to grow and divide and move. So they creep into the injured area and multiply to repair the area and then
if the surrounding organism is able to deliver oxygen and sugar and other nutrients, then they are able to differentiate and finish the healing process.
Right. All right.
So this whole theory of antioxidant, that we don't want to oxidize things, is really we want the cell to be oxidizing, and an injured cell is not using the oxygen. It's actually in an anti-oxygen state. And
if you get stuck in the antioxidant state, that keeps the healing process from being completed, and that's where cancer is. It's stuck in the inflamed antioxidant state,